The word application just means that you're going to be taking the math that you know and you're going to apply it to real life problems. Before we can actually do the application, I have to explain a few things. If you ever hear of an angle of elevation, what that means is that you have, first off, you start with a horizontal line, and that's always important. You start with the horizontal line, and then if the line or if the angle goes up to something at an angle here, so you start at the horizontal and you go up, then you consider that to be an angle of elevation. It's going up. If you want an angle of depression, what you do is you start at your horizontal line and you go down to the other side. So horizontal line and you go down, that would be your angle of depression. So it's really important when you read a problem, if it says elevation or depression, you start with a horizontal line. If it says elevation, you go up. If it says depression, you go down. So we're going to look at a couple problems here. On page 146, we're going to start with example 7, and I have a picture here. It says that you're a surveyor standing 50 feet from the base of a large tree. So looking at their picture, here you are, you're standing right there. The surveyor measures the angle of elevation. So again, angle of elevation, we start from our horizontal and we're going up to be 71.5. How tall is the tree? So in order to do this, the first thing we look at is let's sketch out our triangle that we're given. We have the tree, that would be our vertical line. We have the ground, that's a horizontal line. And then we have this angle of elevation that goes up to the top of the tree. Now we're told that this angle right here is 71.5 degrees. We know we are 50 feet away, so our adjacent side is 50. And the question asks us how tall is the tree. So we're trying to figure out the opposite side. So once you have your triangle built and labeled, now you got to back up and talk about sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So as I'm trying to figure out what to use, I'm looking at what I have. I have an angle. I have the adjacent side and the opposite side. So now I need to identify which trig function works with both the adjacent and the opposite, and tangent works with the opposite and the adjacent. So now I set it up. I fill in what I know. I know my angle is 71.5, so this is going to be the tangent of 71.5 degrees equals the opposite, which is x in this case, over the adjacent, which is 50 in this case. And now it's time just to solve for x. Make sure your calculator is in degrees. So I'm finding the tangent of 71.5 degrees. I've got 2.9886 and so on. By the way, I'm leaving that on my calculator because now as I multiply by 50, I want to take the original thing times 50, not my rounded thing. So I take that times 50 and I get 149.43 feet. So I'm expecting this tree to be right around 150 feet tall. So our second example says you're at a river, you're 200 yards from a river. So if we look at our picture over here, here you are. You're 200 yards from a river because the best way to get to something is to walk in a straight line there that's perpendicular. It's going to be your shortest route. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. Find the acute angle between this path and the river. So they're asking us to find this angle right here. Between the path and the river gives us this angle. So find the angle. Let's see. Let's set it up. So we've got our triangle. This is 400. This is 200. And here's our angle. So let's see here. What sides do we have? We have the opposite and we have the hypotenuse. Sine is the opposite over the hypotenuse. Now my opposite side is 200. My hypotenuse is 400. So my sine of the angle is, well, if I do my math, is 1/2. Now, there's going to be a time where we actually use calculators to figure this out, but right now what I want you to think about is, when is the sine equal to 1/2? Think about the unit circle. Okay, it's positive. We're going to be in the first quadrant. When is the sine 1/2? Is it at 30 or is it at 60? Remember, sine is the y value and 1/2 is the smaller number, so it's going to have to be 30. So my angle is 30 degrees then. One last problem. Here they just graphed out our triangle for us already and asked us to find one of the sides. So here's my angle. My side that I know is the opposite side. The other side is my hypotenuse. So opposite and hypotenuse is sine. So we're looking at sine of 18.4 degrees. Oops. 18.4 degrees equals the opposite 4 over my hypotenuse C. Oh, this is going to be an interesting one. Okay, so if I look at this, I could make this a proportion, so I could put this over 1. That means I'm going to multiply 4 and 1 and divide by the sine of 18.4. So then, as I do that, I'm going to get 12.67. Now, it's always a good idea to look at that and make sure that that makes sense. This is the hypotenuse I just found. So the other side is 4. So is 12, remember the hypotenuse is your longest side, so 12 should be longer than 4, which it is. So it looks like it should be about right. 12.67. If they say round to the nearest foot, I don't know if they do, then we'd want 12.7 feet.